Bandwidth for changelog is provided by Fastly. Learn more at fastly.com. We move fast and fix things here at changelog because of Rollbar. Check them out at rollbar.com. And we're hosted on Linode Cloud servers. Head to linode.com/changelog. This episode is brought to you by Linode, our cloud server of choice. It is so easy to get started with Linode. Servers start at just $5 a month. We host changelog on Linode cloud servers and we love it. We get great 24/7 support, Zeus-like powers with native SSDs, a super fast 40 gigabit per second network, and incredibly fast CPUs for processing. And we trust Linode because they keep it fast, they keep it simple. Check them out at linode.com/changelog. Welcome to Go Time, a podcast featuring a diverse panel and special guests discussing cloud infrastructure, distributed systems, microservices, Kubernetes, Docker, and also Go. We record live every Tuesday at 3 p.m. Eastern, noon Pacific. Join the community that's live with us in real time during the show in the Go Time FM channel and Go for Slack. Follow us on Twitter, we're at GoTimeFM. Listen live at changelog.com/live or subscribe at changelog.com/GoTime. And now on to the show.
Welcome to Go Time. I'm Matt Ryer. Today we're talking about errors in Go. We're going to learn a bit about how they work. We're going to talk to a panel about how they use errors. And we're also going to talk about the future of errors, including some of the new proposals that are flying around. So joining me today, all the way from Australia, it's Dave Cheney. Hello, Dave.
Hello, Matt. How are you?
I'm good, sir. What time is it for you?
Oh, I don't know. It's 10 in the morning, something like that.
Yeah, it's insane. But it's also tomorrow, isn't it?
That's right. Asking what the football pools are.
We're not allowed. The Queen has made it very clear. No leaking information across time zones. I don't know what that means. The editors, by the way, of this podcast do not edit out anything that I say that's ridiculous, by the way. I don't know why. I've got an ongoing feud with them. Hopefully, I'll patch things up. Let me continue to introduce the panel here then, because I'm also joined by, it's only Peter Bourgon. Hello, Peter.
Hi there. I've never been on a panel before, so this is very exciting for me.
Oh, well, glad. Hopefully this is an enjoyable experience. Where are you, Peter, currently?
I'm sitting in my bunker in the center of Berlin, where it is currently 9 p.m. and the sun is still up there. So that's me.
Nice. Berlin. This is a very worldwide show today, actually. We're all over the place. I'm in London. Dave, you're in Australia, right? And Dave, please remember it is a podcast. And I'm going to introduce further guests. This is going really well so far, the introducing guests bit. I'm also joined by, well, it's Carmen Ando, isn't it? Hello, Carmen.
Hello.
How are you?
Good afternoon from New York.
Oh, New York City. How's the weather there?
Hot, like I like it.
Cool. And we also have an additional guest. Usually we don't have this many, but this is a special show. It's Marcel van Lohuizen. Hello. Could you introduce your own self?
Sure.
In my accent.
In your accent? I don't know if I can do that, though. I'll just stick with my own.
Just yours.
Marcel van Lohuizen from Switzerland, also very hot here. And I'm on the Go team, you may know.
Excellent. Thank you. So, yes, we're talking about errors today. And I think it might be nice to just sort of get started and talk a little bit about what it is that makes errors different in Go and what makes them special. Because they are unusual for people when they first come to the language. Does anyone want to chat a bit about the differences there? I mean, essentially like languages that have exceptions, they're kind of always there. They're part of the fabric, really, of everything. Whereas in Go, that's not really the case, is it? The errors are really just values that you can return. And in fact, error is just an interface.
I think maybe what you're alluding to is the fact that in Go, our error handling seems to be very explicit. It's not just the technicalities of like exceptions versus explicit return values. It's more, at least to me, it's the tradition that we have of kind of, people often say you think about the unhappy or the sad path first. And because because the error handling is part of the return value, not any kind of additional mechanism. It's kind of like the thing that you have to think about first. The language guides you to not being able to I'll think about the error handling at the end, or I'll put that in a catch block or something like that. So maybe that's certainly how I think about it, that error handling is explicit, and that kind of has driven a culture of focusing very much on, well, if we solve all the unhappy paths at the end, out of our code falls the happy path.
Yeah. And I think writing code like that also is quite nice. If you do catch all the errors early and do that thing where you return early throughout a function, you do end up with the last line in the function being kind of the happy return. So it becomes quite a handy way as well of just being able to glance at a function and see what's going on.
One thing I notice, especially among people coming from different, maybe not so hardcore computer science backgrounds, is that this style of sad path first, they don't see it as nice at all, right? Their mind is strictly in the business logic of the thing, and they look at error handling as a necessary evil. They want to think about specifically the thing that they're doing, and if it doesn't work, then, kind of, oh well. And I think that is kind of at the core of a lot of frustration with this part of the Go language. People expect to program in one way, and Go kind of, in some ways, forces, in other ways, encourages them to think about the way they structure their programs in a completely different way. And I guess it's open for debate how much of that is good. I would argue a lot of it is good, but maybe there's space in the discussion to say, well, maybe we don't need to go quite that far. And I guess that's what all these new proposals are talking about, at least a little bit.
Yeah, maybe there are two parts to that. The one is the actual, the explicitness of error handling. People would say it's in your face. You feel you need to always be talking about it, always be typing about it. The other one, going to Peter's point about a cultural background, or bringing your history with you. From my point of view, coming to software development from an operator's point of view, always want to know about how this software can fail. That's all I don't care if it works. If it works, that's great. It's not going to page me, but I want to know how it's going to fail. And so that was, I would say, for me, one of the great things that attracted me to Go in the very first place. I'm we always talk about, what if this doesn't work? What if this file isn't here? What if I can't read from it? What if I can't? And so on and so on. And so being able to talk explicitly about the ways that a particular operation doesn't work was like catnip to me. This is great. I want to talk about this all the time.
Yeah, another point is that Rob made early on is that if you have a file that doesn't exist, that is not really all that different from if some values input by the user are not according to some spec and you need to generate some error. These are the same things. So error really shouldn't be handled differently as any other value in most cases.
For my sins, I came from a background of Java where always there was this discussion about the overuse of the idea of exception. We make things which are not exceptions, mainly because of that driving force in Java to unify all the things behind this one exception mechanism. Therefore, every kind of failure, from the trivial to the catastrophic, always smells the same way.
And in Java, they had the unchecked and checked exceptions, didn't they? What were they trying to do with that? What were they?
Does somebody else want to go? I don't want to monopolize the conversation.
No one wants to talk about Java exceptions, Dave.
Well, put me in that category too.
Okay, fine.
No, I put I did some research about this, find out, because the notion of Java's checked exception was absolutely a reaction to the way the exceptions in C++ are handled, which are there was no way of knowing, does this function throw? One of the great sports of C++ is to open up any of the C++ conference talks, and Herb Sutter will put a 3-line piece of code on the page and say, it would be something like adding two numbers together, and he'll say, is this safe? And then he'll spend the next hour talking about all the ways that adding two numbers together can be unsafe, can just blow up. And part of that is because, well, someone might have overwritten addition for that type, and it might throw an exception, and you just don't know. So Java's checked exceptions were very much a reaction to that, which is, if this thing can throw an exception, you have to put it in the signature of the method. Unfortunately, they figured out eventually that was going to require every single thing to have a throws clause. And so they kind of created the secondary category of what we think of in Go not as panic, but as throw. There's a concept inside the runtime. There's actually a function called throw. And throw you can think of as panic that you can't catch. So if you think of checked exceptions, there's category of those, and then there's an even more a larger ones, which are things like dividing by zero, out of memory, things like that, which are subclass from the not checked exception category, but the one that doesn't need to be checked. So effectively, you could throw exceptions and not have to mention them. So all that work to say, right, we're going to make sure that everyone has to write down all the exceptions that their code can throw was kind of undone by the reality that, well, that means we have to write it down everywhere.
And I never used them, but is it true that you had to enumerate all the transitively thrown exceptions from all the functions you called? Is that how that worked?
Precisely. If you didn't catch them, if you passed them up, then kind of the set of possible exceptions grew.
Yeah. Okay.
And so the research that I ended up doing is I said, well, was Java the only ones that ever implemented checked exceptions? And within the caveat of mainstream languages, which is up for your own interpretation, I cannot find another language which went and chose checked exceptions. C# certainly didn't. There's a long thread from 2004 of interviewing with the C# designers, like, so you haven't done checked exceptions. They're like, yeah, we're just waiting. We're going to see how it goes. We might do it later. 15 years later, yes, they didn't. So Java's kind of out there on its own of the mainstream languages that went down the path of actually forcing people to note their exceptions.
Great. And when I write Go code these days, I wrap the errors. If I call some function and I get an error back, almost 100% of the time, I will return that error wrapped in some way. And actually, I use the pkg/errors package, Dave, which I know you worked on or did. So does everyone do that same thing? Does everyone wrap errors? And what's the value in wrapping an error?
I do and don't. So if I want to have context, I wrap it. If I create a new error, I wrap it. But sometimes you're not really adding too much information, and then I don't. So it depends on the situation.
Yeah, I want to just correct one thing. I wrote PKG errors, but it was based on 4 years of work that we did inside Canonical at Juju, and giving credit where credit's due. Like a lot of the ideas which PKG errors built on is built on Roger Pepe's ideas. He had Juju errors and Ergo that he wrote. If anything, the package errors that I have was in my style of throwing out everything which I possibly can and leaving only the bare minimalism. That was all that I contributed to the errors package. But I remember sitting in Starbucks with Roger like 2000 and 2012, and we were saying we had a tradition inside Juju at the time of using form to error f to add an annotation. Because always the classic example, something 20 layers down fails, and the only error you get is io.eof. So we had a tradition of wrapping the errors with formed error f, in the classic style that's documented in Alan and Brian's book, formed error f notation : %v the error, and having that discussion back then. Well, now we've got as a string and have to do substring matching. That's not cool. Like, can we do it better? And that was really where the ideas for wrapping an error so that we could unwrap it, so that we could get the original type back, because back there at the time we were very obsessed with the types of things, and we really wanted to check we got exactly not just an error, but its specific type and perhaps its specific value. So turning it into a string form with funct error f kind of blew all that up. That was where a lot of those ideas came from, the work that Roger and Gustavo did on the Juju project.
One of the nice things I like about that story, Dave, is that errors, the errors package came out of actual use. It wasn't imagined. It came out of real pain that you had. And I think that shows, because every time there's a package that just really hits it on the head, you realize they've just solved their own problem here, and then they've shared that afterwards. Sorry, Peter.
Yeah, and speaking of coming out of actual use, Marcel, you mentioned that you wrap errors sometimes and sometimes you don't. And I'd like to dig into that a tiny bit and kind of ask you, is there kind of a rubric, a way to generalize when you do and when you don't, that is a bit more concrete than, when it feels like it adds information or not? I have my own ideas, but I want to hear yours first.
Sure. Well, so if you have helper functions within your code, for example, and that might change, you're just passing an error through the chain of your code, basically, then some functions don't really add all that much information. So I wouldn't wrap. Of course, there's this other problem that things like packages error solve. If I really want to return some sentinel error, but wrapping it would eradicate that, I have to return the sentinel error. even though I would want to wrap, right? Sometimes you would want to add this information. And for this, standardizing on something like what package errors does is important. But sometimes there is something like too much wrapping. I think you could go there.
Okay, so it's still...
Yeah, generally I would try to wrap more often than not.
So this is also my experience, but I raised this in an issue comment with, who was it? Robert Griesemer somewhere in GitHub. And his position, which I found a little interesting and it makes sense to me, is that you only wrap errors once they cross a package boundary, right? So the package boundary represents some kind of like a barrier beneath which everything else is an implementation detail. And I get that. And I get that in code that has been carefully thought through and produced and reviewed by essentially intermediate or advanced programmers. But it really doesn't match with my experience of working in large teams or consulting or anything like that, where it's very rare that packages are well defined. It's very rare that the modularity of the code is such that packages represent a good coherent boundary. And much more often, I say, just wrap everything. And, maybe if there's a tiny helper function, don't do it there. But the risk of overwrapping, especially in like private code, is much lower than the risk of underwrapping when, the service crashes and you get IOEOF. And I wonder if this, well, I mentioned this to Robert, and maybe it's worth talking here. I wonder if this represents a disconnect in a way between how Go is perceived by the core team, how it's used in real life, and how like maybe those of us a bit further removed from the Go team actually see it being used. And maybe that's something worth discussing, especially in the context of this sort of thing.
Yeah, so I looked at a lot of different types of error uses. So I didn't really go for frequency, but I wanted to see when I did some research in this, like what different error wrapping styles or error creation styles do people have. So I looked at uses for different packages, but also things like upspin.io, right, who's using a different approach to errors. And generally, there doesn't seem to be a lot of consistency here. So there's really a large variation of the way people use errors and wrap errors. And I really don't think there is one good way. So whatever we do, we shouldn't constrain people one way or the other, right? I think it's completely valid in some cases to wrap a lot, whereas in other cases, you really do. So one thing I sometimes do is to not even have an internal type, like a quote unquote error type that isn't even implementing the error interface, and pass that around, and only at a later stage convert that into a different error, right? So that I can really use the compiler to enforce different properties of the error throughout the system until it makes its way out. So this is again very inconsistent with any of these approaches. So yeah, what's important is to standardize in something that I think will still allow all these different cases, but I think they're all legitimate.
Carmen, I know you've done quite a lot of outreach, and probably more than anyone else among us. Do you have any perspective on like ways people use errors or don't use them successfully?
A lot of it is actually looking at some of the data that other people are doing using tooling, including what Marcel's done and including some people in the community running. And it is a mixed bag, and it is so the community contains multitudes. And that also includes people who don't maybe have deep contextual knowledge about the Go way, or really have grokked an understanding of the Go way for error handling, like errors as values, or implementing the error interface makes everything an error. And so there's a lot of conversation and opinions, and it comes back to, my final conclusion is the community because it's bigger, we just have a lot more here. And there's, this idea that there's just one way or two ways to do things in Go no longer holds water, because people are using error handling, trying to bridge from other languages that they're coming from, whether that be Java, dynamic languages that are not really used to this idea of sad path first, or the idea of, like, two things that I kind of really like, or the idea of really understanding that error or failure is the default in any computer programming language. And errors taught me that in Go. And the second thing that I really learned was this idea of mechanical sympathy, which is something that I didn't hear prior to coming to Go and using Go, but now I hear it all the time. And errors kind of becomes front and center in that. And so I kind of went on a little bit on there, Peter, but yeah, it's all over the map.
I also wonder, like you say, doing sort of analysis of the code that's out there, right? to me, automatically biases the data you're getting because, at least in my experience, consulting and speaking to people in meetups and stuff, I would say vast majority of Go code is in private repos, right? And I can say more about my experience of that, but I wonder how we're biasing.
Oh, an enormous amount, a mountainous amount, like that 90% below the waterline.
Yeah, so I wonder if we're making decisions based on patterns we see in open source repos, if we're really responding to Go as it is used in practice.
Don't forget how do you learn anything like from being a child through to being an experienced programmer. First day you sit and you look to the left and you do what the person to your left is doing. What I'm seeing coming into recently, the company I worked for was acquired by another. I'm coming to a very large company that has a very strong graduate recruitment program. So we have the funnel of experience is very, very wide at the bottom. Folks coming out of either interns or their first job as grads, they have only the background. The two tools they have at their disposal are the background that they learnt in university, which is probably driving them more towards Java. There's a huge kind of like tension inside university. Should university teach people to expand their mind, or should it prepare them for industry? There's huge pressure inside the CS curriculums to kind of resolve that in the way that industry wants programmers trained so they can start straight away. So the languages they use a little bit of Python, a little bit of Java. If you're coming out of the Australian system, a little bit of Prolog just to add some spice. And then so that's one tool that they have available to them. The other is the code that they're being asked to maintain, which is literally the kind of conceptualization of look to your left, because the person to your left just wrote that code. And so it can drive an enormous amount of groupthink, of trying to fit in, of trying to model what they see to the left. And what I'm getting at with that is literally like a tiny perturbation of a particular house style will bloom as this is the way that we do it here. To make a completely random observation, you can trace the genus of that PKG directory. I don't want to make this a hobby horse to stand on, but you can trace the genus of that PKG directory that is in all the inside the Kubernetes repos that have PKG all the way back to the way that Go was written in 1.0. For historical reasons, because we had a makefile, packages were in this directory called PKG, and other things were in a different directory. And in terms of like, I see that in this is the big popular Go repo, I will follow that style. So most of what I see in private repositories is across now 6 or 7 different companies I've programmed Go in, is a kind of this is the way that we do it here kind of thing, without a great deal of understanding of why.
Yeah, so what about that though? Because being consistent within a code base, there's value in that, isn't there? So, but do you just mean that there's just this inertia that happens and it just gets unchecked, and that's how a lot of these things can come about?
A lack of reflexivity, a lack of why do we always wrap here? And I think this goes to both Peter and Marcel's point that there's an enormous way that to take the example of overwrapping, of like annotating on every single error return path, comes out of traditions of, well, this is just how we do it here. You get, if you're level 1, you get pulled up on your PR reviews if you don't annotate every error message. I certainly remember that when we were really, really into that in Juju, we were, that would be the number one thing we pick up on. Didn't wrap here, didn't wrap here, didn't wrap here, didn't wrap here. In the same way, it'd be like, always comment your functions, always add a doc string, that kind of thing. So it can be enforced by rote, but also, again, without a lot of reflexivity of what is the value of this. So one of the things that in the errors package that I made a mistake very early on is following these patterns that we'd established in Juju. The first thing I had was a wrap function so that you could, on every error return, wrap on every way out. And then after trying this on my own code for a while, I realized that the message in the code that I wrote was actually the name of the function that it was in. So if it was in an open file, the message would be open file, failed to open file. And so I thought, why am I just I'm literally in code duplicating the stack trace. And so I changed the errors package quite soon after it was released publicly to not just capture the stack line, but actually capture the whole stack trace. Because, and I'm getting to Peter's point, in my mind, if your code is well factored, and the audio listeners, I'm making the scare quotes thing, if your code is well factored, then kind of the stack trace, like the name of the function in the stack trace, is a very good proxy for the little message that you would annotate with. But to get to Peter's point, that's a big if. Like, code is well factored. Like, people have good function names. They use packages. All of these things, which perhaps we as advanced Go programmers, like, well, of course you do all these things. Like, I love to sit down and teach people how to do these things. There is no evidence that those practices actually permeate out into industry, where people are learning either by rote or bringing a lot of their, well, this is how I used to do it at high school kind of, or this is how I used to do it in my last job, or this is how I used to do it in Python when I was a Python programmer, experience to Go. Those traditions don't translate over. So there are error handling strategies. All of the ways that they approach Go code is different the way that but by definition, we are successful. We've all, I think, collectively in this room, been programming for 5, 6, 7, 10 years in Go. Like, we had to be doing something right to get this far. And we're kind of transposing those values onto people without a lot of background.
That's really interesting. I never really thought about that.
This episode is brought to you by Rollbar. Move fast and fix things. Resolve errors in minutes and deploy with confidence. Head to rollbar.com/changelog. Request a demo. Get started today. It's loved by developers, trusted by enterprises, and most of all, we use it here at Changelog. Move fast and fix things with Rollbar. Once again, rollbar.com/changelog.
Whenever I wrap errors, I do it really so that I don't need the stack trace. I kind of, a stack trace would also do for me too. Yeah, it is about just finding out where that error came from. Some errors, like in the OS package, for example, the error will, if you try and open a file and it's not there, it contains the file name, I think, in the actual error message. So you kind of have everything you need, really. You're saying, I'm trying to open this file, I didn't have it. But if I was just opening one file in the program, then of course I probably wouldn't bother wrapping that. But if I'm going to have some program that's going to deal with files, and they've got a few points throughout my code base where I'm going to be doing that, then I'll use wrapping to just sort of tell me where those points are. And that idea of just having the errors, just wrapping them only when they cross the package boundary wouldn't work for me, because internally, I still need to know all that stuff as well.
I think that goes to Peter's earlier point, which is, you all know I'm a big fan of this mantra of like, package should do one thing. Its name should be the ultimate one line description of what it provides to you. That's really not the case in industry. I'm sure all of us have seen so many code bases that packages are factored along Java lines or along Ruby on Rails lines. A package called controllers, a package called forms, a million packages called utilities, or no packages at all. And in that sense of, I just wrote the code in the file because I didn't know where else to put it, without any of that structure, that is where I individually, I find that people write a lot of kind of wrapping comments because they literally don't have any structure in their code to give them to fall back on. It's all just in one big old package, or worse, they've imported a library that someone else has written. That was usually the advice from the errors package. I don't claim to have made it up, but the example, where do you wrap? You wrap when you call into somebody else's code. Obviously that's in a different package, but at the time, before the work that Marcel and Jonathan Amsterdam did, and Daniel, I can't remember his last name, putting wrapping into the standard library, if you're calling to something in the standard library, by definition, that error would be unadorned, unwrapped. So it wouldn't have a stack trace associated with it. And this was the thing that, coming back to what programmers expect coming to Go, is they really expect a stack trace. Whether that's useful or not to them is, I think, independent of the fact that that's what they're used to in other languages. Python will explode with a stack trace. Java will give you a stack trace any day of the week. They're like, I have an error, where's my stack trace? And that was one of the selling features of the errors package. Like, people were like, errors with stack traces, we love it. We understand exactly how this works. So if you want to guarantee that you at least get a stack trace that leads you at least part of the way there, even if you fall into the standard library or some package that somebody else has wrote, at those interface boundaries where you're talking to somebody else's code, that's where you wrap.
There's a point to be made here, and I'm seeing it also in the GoTime FM Slack channel. And that is all the things that we're talking about take a really long time to develop an intuition for, right? And especially in the Go way of doing things. It just takes time, and there's a mental model that needs to build up. And if you're more pragmatic, you just want to get the job done. And so you're looking left, as you say, Dave, and you copy the thing and it compiles and you build it and you run off and you go into the sunset. Just get your job done 9 to 5. And it takes a long time to build up these mental models surrounding like clear package boundaries or how best to use errors, or even like, why would I want to do one versus the other? Are there maxims? Are there proverbs? And it just takes a long time, and it's really hard to teach. And it's really hard unless you are in it every day for a number of months, even years.
Absolutely. So for me, I'm less interested in the idea of wrapping and more interested in the actual, like to bring to today's topic, the actual mechanics of what happens in that if error not equal nil block. All the time that I've been involved in Go, there have been this kind of set of repeated themes of trying to reduce the verbosity of this. Like the meme of Brad Fitzpatrick with his pedal that makes the little stanza is a direct reaction to I dislike having to type the same thing over again. There's an entirely different rant, which will not fit in this podcast, about the evil of the notion of dry above anything else. But there's a reaction to the visceral reaction to the mechanicalness of having to type those, if error not equal nil, return error.
And Dave, if you don't mind, I just want to jump in and maybe highlight, maybe it's worth drawing a distinction between simply the verbosity of that check and all the parts that you have to repeat, including the return whatever within the middle of it. And for me, at least, somehow the semantics of it, and that's probably the wrong word, but the idea, like we spoke at the beginning of the podcast, it's a critical part of Go, in my opinion, that errors are handled directly up front and not kind of deferred to some other scope or some other place where, context might be lost. And for me, at least, that semantic or whatever it is extremely important to keep and to not lose. The verbosity we can talk about. But I wonder if other people feel that, first of all, that if that distinction makes sense, and second of all, if they agree with me.
Yeah, that makes absolute sense. And any of the proposals you'll see from the Go team, they have that property, right? Like we're going to treat errors as values, going to keep the context.
I do not agree.
Well, can you give an example of one where it's not?
I think try definitely does not. And I think that because it's designed as a built-in, as a function, it can be interlaced several times in an expression, and the handling of that error is then deferred to either defer block at the top of the function or the calling scope, and you don't actually deal with it in situ.
So in practice, it's not actually a function, right? It's a macro. And I've stressed this very point that you've made. I've stressed this to Robert, and he assured that we will be able to find the original location of the error.
What do you mean by that?
So the context in which it occurred, right? So if you want to go...
Oh, but I mean visually, like in a code reviews context, not like a stack trace.
So how is that visually not retained? Because a try macro is just a shorter version of the if then else, right? Or if the if then check.
I think what Peter's talking about is that there's an example that's been posted many times in the various issue forums, which is because try effectively 2 values enter, 1 leaves, and because there's only now you get a single return value at the end, you can chain things together. So the example people love to show is try os.open dot doing something with the thing that was read dot doing something that, and stacking them up with tries, using try to kind of turn a multiple return argument back into a single one, and then build that kind of fluent pattern out of it. So on one line, you have many tries wrapped, either try this, dot, try that, dot, try something else, or tries kind of wrapped one in the other. This is a very, very poor medium to express that. But the thing is that you have now this option of this idea of open, read, and close all stacked onto one line, permitted by this kind of try macro or try helper function that is taking the error values, stripping or filtering them out, and then returning you actually the thing in the success case that you can then move on. You go from the very kind of declarative, imperative style of open the thing, check, error, return. read the thing, check error, return, close the thing, check error, return, to a more kind of fluent style of open the thing, read the thing, close the thing, all on one line. Very, very, very neat and concise.
You can do that too with, if you call a function that returns another function that you're then going to defer, then you can cram that onto one line as well, and you end up with basically two sets of brackets at the end, two sets of parentheses at the end. Is it just that we have to be disciplined when we write code and just not do it like that? Or is that nested try thing represented as a feature of try?
I think they've been stressing the discipline part of it. Quite a bit. Like you just shouldn't go overboard with this. If we get to the point that we have generics in Go, like all of this would be very easy to simulate. Also, right? So there is still a matter of a certain style that people should adopt to make things clear, right? Like whether there's try or not, whether there's generics or not.
So this gets, I think, to an interesting, maybe philosophical point, which is there's certainly people that want this chainability, right? People who look at Go and say, well, I don't care. I want to be able to change expressions and just deal with it this way. In fact, there was recently a blog post about the same program written in 3 programming languages. It was an image manipulation program. They did one in Rust, in Go, and Python. And the author explicitly said, I wish Go had this Rust question mark macro or whatever, so I could do all this at once. But my question is, if we give them that, does that not subvert what I think is like a really core principle of the Go, the language, which is that this sort of occlusion of the sad path is like problematic? I mean, I certainly believe this, but I've been doing this for a long time. I'm like fully on board the hype train or whatever. And maybe it's not true. Maybe I am too rigid in this belief, but that's certainly what I think now. And that's certainly why I push back against this kind of thing.
In my own head, if I see try, right, it's exactly the same as what we had before, just shorter, right? But I can imagine that it will be interpreted differently by other people.
Okay, I want to respond to that because the try proposal as it stands now cannot replace every instance of if error not equal nil, which means when you say if I see try in a code review, that means there are plenty of cases where there will not be try. So now instead of having one way of handling the error return from a function using good old if, there are now 2 different ones. The great concern that I have is, again, following this line of try is added to the language. People are going to want to use it. I mean, by definition, why would a feature be added to such a Spartan language if we weren't supposed to use it? That's a really complicated message to try and explain and teach in class, and in explain in blog posts and explain, certainly in my position, explaining code reviews. That using the new shiny thing is actually not appropriate in this case. Like looking at the data that's been provided, let's in any of the data I've looked at, it's less than 5%, less than 1% in the case of my code base. But let's be super generous and say 20% of cases can be replaced with try, like 1 in 5. That means there's going to be this constant pressure in every single code review of like, oh, you should have used try there, and the person arguing, well, I think it's actually more complicated. It doesn't fit into that 20% case. So in attempting to bring a style that favors making the happy path easier, enormously harder for the thing that every programmer does every day, which is negotiate in code reviews by giving an option, by saying, oh, this you can use this most of the time, but actually 80% of the time this doesn't apply well. I think the focus on trying to make the happy path easier to appease people who want this fluent style is, in the broader view that I look at, counterproductive.
So it depends a little bit on the type of code you're dealing with, how often it would be useful. So if you look at system code, or if you look at the Go code base, for example, there's actually very few cases where try will be useful. The higher you go up the stack, the more you're using other people's libraries, the more useful it will get. Sometimes it would even reduce quite a large impact on the size of your code and actually make it more readable, right? So it really depends on the type of code you're writing.
I can't get on board with your make more readable. The point that I wanted to make before is there's a thing that happens inside every error check, and most people don't see it because a lot of the time it's actually invisible. It's the cleanup. The thing that happens in the block once you said if error isn't actually nil, open brace, it happens on that line before you return from the function. And that's cleaning up. That's undoing the work that you've done. And yes, we have mechanisms like defer in that, but the most important thing in my mind that you do in that error path is you put the state back to where it was. You make sure that you can retry that function, or you do whatever it is that, okay, this failed to happen. We need to correct the state and then return out of that function and let the caller deal with its correcting of the state and dealing with the error. And even though it's explicit there on the page, the fact that if there is no line between if error not equal nil and return error, then you know that there is no cleanup. It's not hidden anywhere else. It's not smuggled into a fur. It's not smuggled via some very clever thing of a named return value. You know, right there, that's all we need to. And also, as a code reviewer, when you do see some work before that error return, you know very clearly, I need to pay a lot of attention to this because this is in the error path. This is trying to correct or put the world into a sane state before this function returns. This is the most important thing because this is part of the error handling path, and it's right there in the block.
But if you're not already using the for those cases, you would still be using a if-then check, right?
Yes. The canonical example is the one that we've always bat around, which is file copy, which is you started to open one file, you started to make a new temporary file on disk. Defer isn't going to help you because that's only applicable for actions that happen on both success and the failure case. Normally in those file copy type examples, you have to, in your error path, if you're at the point where you've created the temporary file, you need to delete the temporary file so the world goes back to how it was beforehand. So as you say, that's not applicable for try. And I think that's kind of my point. I think there is a pressure to try and find more places to make where try could work because there's no point in adding a feature that no one can use. But from my point of view, that this explicitness is something that is to be cherished. Like, it's super critical to making reliable code, and any moves to kind of hide that, or in cases where it's not important, introduce a kind of simpler syntax, misses the point. It dissuades programmers from thinking about error handling first. Yes, it is annoying, but you have to do it first if you want to write reliable programs.
Is it a bit like Go Run? Because Go Run is kind of, we probably don't use Go Run in production anywhere. You know, we use Go Build, we build the binary, we deploy binaries and things like that. But Go Run is useful at the time when you're just sort of playing around with things and you want to just, as you're learning, really. Go Run can be useful to just run it doesn't matter. It's kind of magic. It's doing a build secretly in a temp folder and things. But it's okay because, it's a learning tool. Does try fall into that?
I think if you have to assume, that if you're providing functionality like try, it will be ending up in production code all over the place. So if it's supposed to be that, then it shouldn't be added.
Right. So it's not just for learning only, but what I mean really is then, if you were going to write a really simple program, I could see a case where you just use try because all you're going to ever be doing is returning the error. And you could write that program, and it maybe if you come from a language with exceptions, maybe that would read in a more familiar way and things. I mean, I'm just trying to explore that because I personally, just because of the way that I do wrap all over the place, I don't think I would use try very often. And then I'm in the situation where there are, like Dave said, there are some of the code has try, some of it doesn't. And there's a few other things that I feel like I would lose as well. Something that I noticed I do is the shape now of this little if error doesn't equal nil check. That, when I scan through code, that tells me something about the landscape of this code. It really helps with the sort of scanning it. And I wonder if we'd lose that, or, I mean, if it was everywhere, I feel like it's okay. But the fact that we're going to have a mix of it, I don't know. Like, it feels like multiple ways of doing something and the trade-offs and things. Yeah.
I'm sensitive to that same kind of instinct that, something exists now that is useful to me. The structure of there's a special word for this thing where like everything's only one level indented. It's like it's even listed in the code review comments. Anyway, whatever that property is, it's nice. I like it. I can leverage it now. And this new thing will change that. But as I'm getting older, I realize this is the same format that a lot of things take that eventually turn you into an old man yelling at a cloud. I at least personally try to dial that back down a little bit. Maybe it would be worse, maybe not. I'm not quite sure. But I guess there's one thing actually, sorry to grab this again, worth highlighting, which is that, which I think you hinted at, which is that, we may not use it in our typical error handling patterns, but plenty of new people will, right? And at least I believe a lot of new people will overuse it. And it will be our job as like code reviewers to say, it doesn't make sense here, it doesn't make sense here. The point is that we're all kind of like, we're not programming in isolation. We don't have to worry about only our use. We have to worry about the use that other people have and the code that we will see that other people will commit and push and we may not have a voice in. So it's like, should a language feature, guide people to the right path gently, or should it just, be there and you can use it if you're a power user? Should a language feature have an opinion in this kind of discussion? I have my opinions. I don't know. Other people probably think different things. Are there opinions about that here?
I've tried to think this from the perspective of maybe Robert or Russ or the Go team who's getting this input, even if it is maybe sample biased by surveys or votes on Twitter or not. And I think language design is hard because Dave had a wonderful proverb in his error handling gracefully Gopher 2016 talk, and that was the frog in the well. Do you remember that, Dave? It does not know the ocean. And I sometimes wonder if that can work in the opposite direction, meaning, what percentage of people are Go programmers out of the larger world? Is it 4? Is it 6? Are we a small bunch? And we're a small bunch that has gotten acclimated to things. And is adoption being checked because we are so kind of rigid about the way that we like the things, because we are the old men and women yelling at clouds, or to keep things how we want them. We're curmudgeons. And so it's hard. We can certainly look at maybe the consequences of try being adopted, and we can know the known knowns, right? We know that this will probably create a conceptual overhead when reviewing and reading code. We know that this might mean that they're going to need a style guide, or we're going to have to say we're a strict try shop, or we do not use try here. I mean, there's going to be consequences. But what we don't know, and this is kind of having to look at a crystal ball, and this is where the perception gap comes into play, is who that would benefit, right? And we kind of can make some guesses, and we kind of can make some assumptions and say, oh, it's not really going to benefit because it's not really using it's not an all or nothing, or it's not a comprehensive error handling. But it is much harder to do that. And so I'm kind of trying to put myself in the Go team's shoes and look at the constraints that they have, right? There's solid complaints coming from the community. They have to assess the authenticity and not authenticity, but just like, okay, are we biased in looking at these complaints, and do we have a sense that this is a priority for us to fix? And looking at all these other things. I see you raising your hand in the vid chat, Dave. I'm giving it to you.
You opened a bunch of really good points there, and that is about, is our stodgy ways holding adoption back? I can't say strongly enough, no, it is not. In the last 2 months, Go for China had 2,000 people in it. We haven't even got that in GopherCon. The usage of Go is exploding everywhere. And to talk to, is error handling holding Go back? Absolutely not. We didn't even know that from the own survey data. It's 5%. It's number 5 below web development on people's list of complaints. I cannot find any evidence to suggest that belief the velocity of Go error handling is true or is holding adoption back.
And just to maybe add on to this point a little bit, like, even though it is a complaint somewhere in the list, I don't think anyone's really given voice to specifically what the problem is, only that the current state is too much or verbose or something like that, which, is like an interesting and backs Dave's point, I think.
So, sorry to jump back in. The data which everybody seems to be rotating off is the Go survey told us that error handling is hard. What the Go survey didn't say is, do you want to add try? It said, Go error handling is hard. And for the 5% of people, it said that's the hardest thing about using Go. Marcel and Jonathan did a huge amount of that work in adding errors is and as, adding wrapping into 1.13. I think there's a false dichotomy of rejecting tries is implicitly rejecting all the people who wrote in the Go survey, error handling is too hard for me. No, it's just one.
One related topic to this. So I have my own reservations about try. It's not all colorful, but one thing, it's absolute prerequisite for try to succeed, if it were there, is to have something like the package that Russ proposed, like the RD package. It's a working name, let's say, but you would need to in order to still do wrapping when you use try, you need to have something that facilitates wrapping in a defer. Otherwise, it's not possible. So what do you guys think of that kind of style of wrapping, doing it in defer? I'm curious to hear your thoughts.
I think it's an abomination. I think the use of forcing people to use named error returns so you can caption them in the defer because the try syntax is so weak is an abomination.
Peter, you like it though, don't you?
I won't go all the way to abomination, but I can say that I have never wrapped errors in this way. I never have. I've never suggested anybody do it. It's not intuitive to me. And actually, the first time I ever saw it was in, I think, the check handle proposal that I even considered it could be a possibility.
Using defer kind of takes it away from the code too. So if you're that kind of thinker that wants to keep it close to where it's happening, as you go down the blocks, that's the other kind of downside that I think from the way that I like to think and use errors.
Yeah, with the check handle approach, one of the complaints was that if you go by the normal recommendation of wrapping errors, you'll end up, this is not often the case, but very often you will end up with wrapping, like calling the same kind of Plymouth error Fs all throughout your code, right? With the same message, the same arguments. And because that becomes so repetitive, people would just prefer to not wrap at all. Right, that was part of the assumption, or what seemed to be the case. So providing doing it in the defer was also not possible because it was just too slow. So the check handle sort of addressed that issue. But now with defer becoming very performant, it could be different. So one point, Peter. So another advantage of wrapping in defers or having this kind of idiom, it also allows us to address some of the other problems like checking an error on close if you defer a close from a writer and things like that, right? So this idiom might also help solve those other things that are really complicated in error handling right now. This is not really what we're looking at, but it opens up some opportunities to address things that a lot of people get wrong, right? And that are very hard to explain how to do it right.
So I just observed two things. One is that I haven't personally seen repetition in locally wrapped errors, but I think that's because I don't wrap the error to say failure in the function that I'm in. I say error in the thing that I called, right? And this is kind of a style difference, but until I had read these proposals, again, I've never seen anyone say error in the enclosing function. That's always been the responsibility of the caller to sort of recontextualize the thing that they called. So maybe it was a file operation, but I don't want to expose that detail to my callers. That's a decision that I make.
This episode is brought to you by GoCD. With native integrations for Kubernetes and a Helm chart to quickly get started, GoCD is an easy choice for cloud-native teams. With GoCD running on Kubernetes, you define your build workflow and let GoCD provision and scale build infrastructure on the fly for you. GoCD installs as a Kubernetes native application, which allows for ease of operations, easily upgrade and maintain GoCD using Helm, scale your build infrastructure elastically with a new Elastic agent that uses Kubernetes conventions to dynamically scale GoCD agents. GoCD also has first-class integration with Docker registries, easily compose, track, and visualize deployments on Kubernetes. Learn more and get started at gocd.org/Kubernetes. Again, gocd.org/Kubernetes.
Marcel, remember in Paris we had lunch in Paris. It was beautiful. But we talked about this, and that's where I started to wonder whether I was wrapping things incorrectly, because I do what Peter described, where I wrap to describe the thing I've just called. I'm not describing this function that I'm already in, and so that's why those just setting the same message for within one function, wrapping in the same way. I never did that. And it hadn't occurred to me that you actually could either.
Yeah, there's different styles in that, and that's why you often see the stutter as an error, failed opening file, error failed opening file, right? And so the idea is, the usual convention was to not repeat what the error that you're wrapping says, right? But yeah, it did go astray in a lot of places.
That was definitely something that I noticed in package errors, that immediately on having the ability to add a little message when you're annotating the stack, when you're in the return path, I realized I was just saying the same thing over and over again. And that drove me to say, well, most of the details of what the thing was doing, if your function is well named, it is actually in the name of the function. Like the name of the function, if you call the open file and disk function, what do you think failed when open file and disk didn't work? And so that drives me more to a notion of wrapping at the package level when you're moving between domains, when you're moving between different purposes.
And the other useful thing to add is arguments to that, so argument values. But yeah, generally, I think what you're saying is right. It should be in general sufficient for wrapping errors.
Sorry, and I remembered my final point, which will be quick. The other thing that a defer block does is it splits your attention between the error as it exists in situ and other things that happen elsewhere. Sometimes it's necessary when you need to do cleanup like on a file, but I think those things are exceptions. And I think most of the time having all of that important context right there is actually a really huge virtue that we should be careful dissuading people from taking advantage of.
Yeah, if try becomes very popular, or it becomes the question of like, why aren't you using it? You can imagine the classical big method that try everywhere down there, because it's like on a lot of the cloud management code I've written, everything returns an error. So these functions are very long because you're building up a lot of state, and then your little defer handler has scrolled off the screen where it used to be right there in the error path. Some people say verbose, other people say explicit. I think they're actually saying the same thing.
So one of the problems is there's a certain number of people, let's say a certain percentage of people, that if it gets to this verbosity, their choice will be to not wrap at all, right? So the idea partly is how do you find a happy medium so as to encourage most people to at least wrap something when that would be a good thing to do, right? So that's sort of a trade-off you make.
Yeah, and I wonder if try does that. It probably wouldn't encourage that, would it? It encourages... It feels like it's kind of all the features of the language, it stands out as being the least Go-like, only because, it is a bit magic. It can return, we don't know how many arguments it returns, right? It's a macro, so I guess it's not a function, doesn't have a set thing. Whenever there's two arguments, the optional second argument, for example, that stuff actually, I feel like we should just always have the second argument and deal with it. Like, that's what I always do when I write code. Say if I'm going to check for a value in a map and cast it to a particular type, I'll always check to see if that's succeeded or not. I won't rely on the panic just because I don't really like panics. And there's it just feels like that it's certainly the most magical proposal I think we've seen. And it certainly doesn't feel like some of the core principle of why I like Go is about this being very explicit. And it feels like this steps away from that a little bit. And the question really is, are there other people for which this trade-off is then worth it? Like, if this meant that the language, you could learn it much quicker, or anyone that's... Because it's true that I've heard it a lot that when people are learning Go and they see this all over and over again, they'll say, I'm not going to learn this. I have to keep typing this. In C# it was automatic. I had exceptions. And it's not really the point, of course, but I wonder whether there's an audience as well that isn't us, a bit like what we've talked about here.
No, especially for things like generics, right? We've definitely gotten feedback like our teams, even if a lot of the team members were encouraging it, some manager override, we will not adopt a language without generics, right? That doesn't still mean you need to add it, but this stuff happens quite a bit, right? And then what do? Right, you want to increase adoption. That said, right, like there's nothing is set in stone with respect to try at all, right? These things are put out so that people can, start to imagine, like, how would it look like? How would Go look like using this? Would it benefit? Would it get shorter? Would it get awful? By putting it out, it also allows people to come up with examples like, look, this is really a horrible idea, right? Don't do this. So either is an option, right?
Yeah, and this really, hopefully this show also contributes to that conversation as well. Robert, in one of the issues, suggested people write experience reports. Is that something that our listeners should do if they've got something particular that they want to contribute on this subject?
I think it's useful. Yeah. I mean, it's the question is, and how far are they representable for the programmers at large? But
Yeah, I think you had some observations on that, Peter, of how well in our little community that we can get on video conferences and talk on Twitter, like how representative that is actually of the actual corpus of Go programmers. What does Russ estimate it to be, like 1.5 million? Sure as heck isn't 1.5 million on any of the social forums where Go is discussed that I'm aware of.
Yeah, there's definitely a vocal minority. And you asked Matt, like, is this going to be useful for people maybe in the C# community who just get it out of the box in the language? And I think it's super interesting that language design and looking at the evolution of it, like Rob Pike even talked about this. I think it's almost poetic, like 10 years ago, I think it was at OzCon, the public static void talk. I don't know if I'll link it, but it's fascinating because he quotes the Lisp Gabriel. Like, I'm always delighted by the light touch and stillness of early programming languages. And then he talks about how Java and C++ are now 10 years old, and now Go is 10 years old. And we're thinking about this idea of inclusion. And inclusion has and always will have trade-offs. It's a paradox. And so that's the kind of thing that I'm wondering, like, okay, do we include to sort of make people who are really used to and entrenched in their deep mind meld of their other programming languages, to include them into the Go fold at the cost of alienating Go programmers? And that's really a hard question to answer. I'm happy I'm not on the decision-making side of this.
I totally agree that this is hard to answer. I think that it's almost impossible to come up with a correct or even optimal answer. And in this situation, I think the right thing to do is to instead try to come up with a framework. Like, what is a framework you use to decide what changes we should make, what we should push back on? And as far as I can tell, or what makes the most sense to me, is that framework is distill the language down to its core principles, right? And, we can argue about some of them, but it feels to me that explicit error handling in situ without exceptions and all these other things is one of the core principles. And if that's true or not, I don't know, but this feels this way to me.
So yeah, I think that where we may disagree then is that try to me is still explicit error handling, right? So it's not exception. It doesn't fall in the exception class of error handling, at least. So one thing that I did or try to do when I'm writing code is like always think, how would this language feature work, right? And then I often write my code twice. So once with the new features, and of course it won't work. And then I throw it out, write it the way it would be, just to get a feel on how would it be, right? Or how would it look like if we have this new feature? How would I feel about it? How would I structure things differently? And that gives an interesting idea on where it could be.
So on the subject of try, and a number of people have tried it. Like people have looked at kind of statistically. Others have said, "Oh, I rewrote my code to look at it, and it looked it made it shorter, as if shorter is like a goal." But the point I want to make there is that we are experimenting with code that already works. We are taking programs which we have already correctly implemented the error handling, correctly tested, correctly fixed all those paths, and then adding a little, as you called it, a macro, adding a little syntactic macro on there to clean it up a little. We're not starting with new programs. We're not starting with new programmers trying to understand how their program operates using this new feature. We're just think of all the things that Go Fix did over the time, how it made our code shorter. And we're like, yes, it worked before, and now it's a bit shorter. I don't think it's correct to apply try to an existing code base, which we know very well, which we know, and say, oh, in those cases where it could, in this small set of cases where it could clean up the error handling, it has made this a little bit shorter. People look at the size of the diff as some kind of success factor. It made my code shorter. It made correct code, which was already working, which was already tested and already new, shorter. I don't think we can extrapolate that to writing a new program.
That's a fair point. That's quite an interesting one.
I want to go back to something Peter said and something I wanted to follow up with about inclusion and things that I'm also seeing in the chat, which is inclusion is important, but maybe the way forward is also really making an effort to teach newcomers to the language about why these things are the way they are. And so having that as a way forward and when Peter, you say like distilling it down to just core language features and making sure that, we always as learners are trying to bridge from existing knowledge, right? We have existing mental models and we have existing ways of doing things and we look left. And I think that having something that's educational might help with this and is also another way sort of attacking the problem, if you will.
Yeah, I think that's right. And to address Dave's comment, it's not always about just being shorter, right? Like on a lot of the examples I looked at, or a good chunk of them, using things like check, handle, or try didn't actually just make things shorter. It made the essence of what the code was doing clearer, right? And these were cases where you would just have repeated thumbed RFs or whatever, and they're getting in the way. Sometimes there were as much as 50% of the code. And it was just hard to see what the code was actually doing in the meantime, right? You could have factored it out, different functions, but that's not necessarily making things better either. And this was some good quality code, right? I'm not talking about some crappy code that was out there that looked better after using it. So there are cases where I think it really make things clearer, these kind of concepts.
I don't really want to say to counter that point, but I do want to bring it back to something we mentioned kind of at the beginning of the show, which is that in a lot of cases, and from some people's perspectives, most cases, or even all cases, the error handling doesn't distract from what the code is doing. The error handling is often the most important part of what the code is doing. And at least it seems to me that Go's perspective from the very beginning has very much been aligned with this, that the SAD path first is how you should think about constructing reliable code. Now, we can talk about whether the characters fmt.errorf and all the kind of ceremony that goes with that is necessary. And I think probably there's a good case to be made that it's not. But I'm not sure that, a counterpoint might be that all that stuff you say is distracting is actually as important or even maybe more important.
I would agree with anything but sort of a wrapping string, right? That just add messages, and these can get pretty verbose and in the way of sort of visually being able to see the program. It becomes sort of visual overload. If you were just returning the error plainly, it would already get clearer, right? But that we don't want, or in many cases we don't want. If you add any code in your error block, by all means, that should stay there, right? Like you should not replace that with try.
Yeah, then I guess it's just a matter of opinion. Then does the prefix string or whatever confuse things? And I guess for me at least, it never has. But I can understand for some people it might.
Well, the point of it is to add information, isn't it? The point of it is to make that more clear what's gone wrong.
Yeah, but if visually 50% or 60% of the characters on your screen are related to error messages, it's just a visual overload to see what the code is doing besides of that, right? It should be in proportion.
Yeah, I tend not to read code sort of top to bottom like that. I tend to jump around a bit more, and that's why I always try and do that line of sight thing. Have the happy path down one edge and indent to solve the errors and handle things and do the early guard and all that stuff. That for sure helps with this kind of glanceability. But what's nice is to be able to jump straight to a point in a file and then see what's happening. And to be fair, try doesn't stop that. You would just be, in that case, returning the error untouched. But I've never felt like the error handling bits got in the way. In fact, they're there where I need them when I'm maintaining code as well.
And you're right, by the way, that if you have no indentation, if all the indentation in the code is related to error handling, it actually works quite well, right? It's the cases where you have one extra indent, where you have sort of normal happy path, where it starts to get annoying, right, to read.
Yeah, but I suppose try would get rid of the indent, wouldn't it, for errors?
Yeah.
Again, I could just be like, I feel like I've got something that I'm going to lose, and that worries me. But I feel like there's value in that stuff, and I'm glad that is sort of part of this conversation too.
Yeah, and again, like a whole argument from the try proposal, or a whole result from the try proposal can be, we are now much more confident, or can much more clearer express to newcomers to Go that why we don't have something like try, right? That can very much be it.
Yeah, I like the idea that we have a historical artifact that says this is why we know it won't work. The other thing that I just keep thinking about, you use the word glankability. We've talked about it in past podcasts, Matt. We talked about readability. Rob Pike has said readability is paramount, but readability is still quite subjective. And it can be also very personal to the programmer. And so we can fall into bias there as well. And I did want to mention that. But again, it becomes like I have a neural groove that's well worn. I start to look for familiar patterns and shapes. If you change that shape, you're adding a conceptual overhead that I don't want. And that's why change is hard. But I just wanted to mention about that. Kyle Robinson, he's in the JavaScript world, and he wrote You Don't Know JavaScript, but he had a lovely talk. I'll try to find the link about readability and, the assumptions that we make about terseness versus verbosity and all the other things, and just kind of trying to contextualize that. And I wonder if we can have an equivalent for Go. That would be great.
Yeah, it's funny on that. I'm one of those people that loves it when there's a new feature. I get really excited. So that's it's not that for me, for sure, because I love when they add new things. It's more about whether this fits in as like the rest. It's that it's the fit, whether it fits or not. But this is, I'm afraid we've run out of time, but this has been a very interesting discussion. Thank you so much to my panelists and my co-hosts, Marcel, Dave, Carmen, and Peter. We will see you next week.
All right, thank you for tuning into this week's episode of Go Time. If you're not yet, hang with us and go for Slack. We have a channel called Go Time FM. Look it up, you'll find us. Hang with us during the live shows, connect with other members of the community, share stories, share code, share coffee recipes, whatever. It's a lot of fun. Also, we have discussions at changelog.com on every episode. Head to changelog.com/GoTime, find this episode, and discuss it with the community. Also, thanks to Fastly, our bandwidth partner, Rollbar for helping us move fast and fix things, and Linode for hosting the Changelog platform. Our music is produced by the mysterious Breakmaster Cylinder. And if you want to hear more awesome podcasts like this, subscribe to our master feed. It's one feed to rule them all, plus some extras that only hit the master feed. Head to changelog.com/master or search for Changelog Master in your podcast client. You'll find us. Thanks for tuning in. We'll see you next week.